Good morning, students. Myself, Vijay Shankar from EC Department, Civil Engineering College. Today, we are going to discuss about some more examples in the II-3 electrostatics. A uniform line charge ρl is equal to, given the 2.5 microcoulomb per meter square, lies along the z-axis, and a concentric circle cylinder of radius 3 meters has a surface charge density is ρs is a minus 0.12 microcoulomb per meter square. Both the distributions are infinite in extent with respect to the z-axis. Using the Gauss law, find the d bar in all the regions. The region is a free space. Okay, let us take it is a uniform line charge 2.5 microcoulomb per meter square lies along the z-axis on a concentric circle of the radius 3. See, for this radius of 3, there is a ρl 1, that is a 2.5 microcoulomb per meter square with the radius of 3 meters concentric circle cylinder, has a surface charge density at the ρs, and this is a surface charge density is also there, minus 0.12 microcoulomb per meter square, line charge and the surface charge, the radius of 3 meters concentric circle, and both the distributions are infinite in extent with respect to the z-axis. Using the Gauss law, find d bar in all the regions. The region is a free space. Okay, the ρl is a z-axis with a circle having 3 meters, and this sphere is also having the charge, that is an infinite charge ρs, and for the z-axis also the ρl charge is there, charge distribution. So let us take this, d bar is equal to dr into ar bar direction. The ds bar is equal to the cylindrical coordinate system. In the cylindrical coordinate system, ds r bar along the r direction means ar bar. There is any component of ar. The components are dr, r into d phi, and dz. These are the three differential elements in the cylindrical coordinate system. It is ds r bar is equal to, along the r direction means there is no any dr bar, and r into d phi and the dz. Okay, r d phi dz into r. According to the Gauss law, we know the q is equal to integral d bar dot ds bar, that is equal to the d bar is nothing but the dr into ar bar dot r into dr phi and dz, that is also the ar bar. Ar bar dot ar bar is equal to 1. So dr into r d phi dz. Okay. Now the dr is a constant term and r is also the constant. D phi, the phi is equal to 0 to 2 pi, and the dz, it is given the length is 0 to l. So after that, the q is equal to, we got as a q is equal to r into dr, and the integral of d phi is a phi, upper limit is a 2 pi, so you'll get the 2 pi here, and integral z is also z, upper limit is a l. The q is equal to r dr and the charge is given, the q is equal to ρl into l. Ρl into the l. We got the dr, r, d phi, and the l as a q. And now, but the line charge is given, the q is equal to ρl into l. So actually it is a dq is equal to, okay. So that rho L into L is equal to, here you can write as a rho L is equal to R into dr d phi into L. So both sides L is get cancelled. Then you'll get the dr is equal to rho L by 2 pi plus the dr into AR bar. The dr we got a rho L by the 2 pi R into AR bar. So actually this infinite line charge electric field intensity, we know the rho L by the 2 pi epsilon naught R into AR bar. Electric flux density is a rho L by the 2 pi R into AR bar. The given rho L is given 2.5 × 10⁻⁻⁶ and 2 pi R, and here the R is in between of the 0 to 3 is a region. Okay. As a sphere B is a Gaussian surface enclosing both the charge distributions. Due to the line charge, D1 is equal to rho L by the 2 pi R into AR bar remains the same. And due to the cylinder of radius 3 meters, let the D2 here, D2 is equal to, that is also Q is equal to dr into R into 2 pi L. But the charge Q is equal to, so previously we take the rho L into L. For the second one, there is a surface charge density is also there. That Q is equal to rho S into ds. Actually, dq is equal to rho S into ds. That Q is equal to rho S into S. Rho S into S. S is the surface area. You can take the surface area of sphere, the 2 pi R into L, where R is a 3 meters and L, you can know, substitute that values here, minus 2.26 into 10⁻⁶ L is equal to, this is a value we got here, the Q is equal to, after substituting the values of the 2 pi into R is a 3. Okay, and the given the rho S is a minus 0.12 10⁻⁶. It is not the 10⁻⁻⁻ plus 6 my students, it's a minus L. Already we got the Q is equal to D2 into R 2 pi L. So LL get cancelled. D2R is equal to, in terms of the R only, it is a R is greater than the 3. Okay, so D bar is equal to D1 and the D2. The 0.378 by R into AR. This is a total electric flux for the surface is distributed, and also the line is distributed with a radius of 3. We find the D1 and the D2. What is a rho L, and for this a rho S. D2 for the rho S and the D1 for the rho L. Line charge and the surface charge, both the combination, the D bar is equal to, we got the 0.0378 by the R, and you can substitute the R is the greater than the 3, or it is a 3 value. The next example you can see, somewhat is another different type of example for my students. Find the divergence of A bar. Find the divergence of A bar at point 2 and 1. Okay, where A bar is RZ sin phi AR bar plus 3 RZ square cos phi A phi bar. We need to find the divergence of A bar. The divergence of A bar Means here the formula we know, the divergence of A bar is equal to 1 by R into AR, or AR is equal to, here the formula is 1 by R into dou A phi by dou phi and dou by dou Z of AZ value. Okay. And actually, it is not the 1 by R, only we can keep the 1 by R for the differential elements we have for dr, R into d phi, and the dz minus 1. Okay. So, you can take the R value, the 1 by R into dou phi into A phi bar, and here the dou by dou Z of AZ term, and here the AR. The R is with respect to the dou by dou R into AR bar. So AR is equal to, what is the AR is equal to the R term. AR bar term is RZ sine phi, and A phi term is the A phi here. So actually the A bar is equal to, we need AR into AR bar plus A phi into A phi bar plus AZ into AZ bar. Okay, but there is no any AR term here. There is no any AR. The coefficient is given, AR is there, but there is no any Z 0. Actually, it's a given, it is a 0 into A Z bar. So AR component, what is the AR? The coefficient of AR bar, RZ sine phi, RZ sine phi. And A phi means the A phi bar coefficient. A phi is nothing but capital A phi. It is a 3RZ square cos phi. And the AZ coefficient, nothing but the capital AZ, is a 0. Now you substitute in the divergence of A bar, 1 by R into dou by dou R of R into, what is the AR here? The component of the coefficient of AR bar is R into Z sine phi. And similarly, 1 by R into dou by dou phi, and the A phi component is 3R Z square cos phi plus 0. Okay, 1 by R into dou by dou R of this total function is constant Z into sine phi. Dou by dou R is something but the derivative of R square. What is the derivative of R square? Is a 2R. And 1 by R here, 3RZ square. 3RZ square is a constant. And cos phi. What is the derivative of cos phi? Minus sine phi. Okay, let's substitute here. Then simplifying the function, 1 by R Z sine phi and 2R are get cancelled here, and here also the R are get cancelled. Then 2Z sine phi minus 3Z square sine phi. And with the quadrants are the R, phi, and the Z. Substitute R as there is no any R term here in the divergence of A bar, only the phi and the Z. What is the phi here? Sine pi by 2 is a 1, and here also sine pi by 2, the Z is equal to 1. Simplify the function, we'll get the minus 1 at the point P. Okay, my dear students, the divergence of A bar formula, the 1 by R dou by dou R of R into AR bar plus 1 by R into dou A phi bar by dou phi and dou by dou Z of AZ. Got it, my dear students? The next example, you see the given in the cylindrical coordinate system, there is no any A phi. Evaluate both sides of the divergence theorem for the volume enclosed by R is equal to 2, Z is equal to 0, and Z is equal to 5. So the divergence theorem, see according to the divergence theorem, converting of a surface integral as a volume integral means a dot product. Okay, the given it is a bar dot ds bar is equal to Evaluate both sides the divergence theorem for the volume enclosed. Given the volume is the integral volume, the surface integral is converted into the volume integral, means del dot whatever the value here, del dot A bar. Okay, according to the Gauss law, d bar dot ds bar is equal to the converting of surface into the volume means del dot d bar into dv. That is equal to q actually. That q is nothing but dq is equal to rho v into dv, we know. Got it, my dear students? Rho v into dv. Apply the integral on both sides. It becomes of q, the volume integral of rho v into dv. So what is the q now? The volume integral rho v dv is equal to integral volume integral del dot d bar into dv. Both sides of volume integral del dot d bar is equal to rho v. This is one of the Maxwell's equation. So already we know that surface integral, how we convert into the volume integral. Whatever the a bar is there, del dot a bar into dv. If I am now finding the surface integral, the integral surface a bar dot ds bar is equal to, for the cylinder means side, bottom and the top, both we have a bar dot ds bar, the integral values. First of all, you can find the a bar dot ds bar. A bar is given in terms of AR coefficient and AZ coefficient. ds also we can take as a differential surface area normal to R direction, means there is no any R component, R into d phi dz AZ bar. Okay. Now the given function a bar is 30 e power minus r AR bar minus 2z AZ bar dot product you can apply for the R d phi dz. Now see the AR bar dot AR bar is equal to 1. The remaining the term is a 0. This is a AR bar, my students. Sorry, it is not the A dz AR. So 30 into e power minus r into r d phi dz AR bar dot AR bar is a 1. For the second term is a 0. So now we can apply that integral here. Integral a bar dot ds bar as 30 e power minus r into d phi dz. Okay, means the phi is the 0 to 2 pi and the z is given from 0 to 5, the integral value. So now you can apply the integral here. Phi as 0 to 2 pi d phi and 30 into e power minus r into r. Another integral is a z. Z is equal to, given it is a 0 to pi dz. What is r here? R is equal to 2. Substitute the r value. 30 into e power minus 2 into r, that is the value is a 2. And d phi, apply here upper limit is a 2 pi, and for this also upper limit only will get the phi. So 30 into 2 is a 60, 60 tens 600 pi e power minus 2. And so can find the value you'll get as integral value. Okay. I think this totally the value is 255.9, not the 9, 255.1. And for the top surface, you see here we got that value, the 30 into 2 is 60, 60 into here the 2 pi is there, that value is also 60, and the upper limit only will get the 2 pi, and here also the upper limit is a 5, totally the 255.1, sorry. And ds bar on top has the direction is AZ bar. Okay. Normal for the side surface is the AR bar, and now is the top surface is a Z. So now I can apply the same thing for the AR bar. A bar dot DS bar is equal to Z component we have. That Z component is given is the integral top. We can take that is equal to, that is integral of top minus 2 Z AZ bar dot R into dr d phi AZ bar. Okay. Now that we can having only the 2Z R dr and the d phi function. So substitute the value here. AZ and AZ component is only the one, minus 2Z R d phi and the dr and d phi, and R, integral R is R square by 2, upper limit is a 2 and the 0, because the R is given the 2, 0 to 2 can take as the upper lower limit and the upper limit, minus 45. Similarly for the bottom surface, the direction is a minus AZ bar, and is a minus into minus is a plus, will get 2Z R dr d phi. The same thing you can apply here, and it is a AZ and AZ is equal to 1, but at Z is equal to 0, the bottom surface shows in the figure is a Z is equal to 0, means the value is 2 into Z. So Z is equal to 0, the term bottom surface is a 0. So integral A bar dot ds bar is equal to 255.1 minus 40 pi. So 45 pi for the top, and this is a side, and the bottom is a 0. So totally 129.4363 we got. And evaluate the A bar dot ds bar in the volume integral. The volume integral means you can find that is a divergence of A bar. Del dot A bar is nothing but the divergence of A bar. In the last example, we seen the formula is there 1 by R into dou by dou R of R into AR bar, 1 by R of dou A phi by the dou phi, and dou AZ by dou Z. AR component, the given AR bar component is 13 to e power minus R, A phi is a 0, and AZ is a minus 2Z. The first what they given here, AR component 13 to e power minus R, and AZ is a 2Z, and there is no any A phi, so A phi is a 0. Okay, dou A phi is a 0, the second term is a 0, and apply the derivative R into e power minus R. So the UV rule, first of all you can take R and apply here the e power minus R minus 1, and again take the e power minus R and apply the derivative for this one. And dou by dou Z of minus 2Z is minus 2 and 1 here. Substituting the values of Z is equal to 0 to phi, and R is equal to 0 to 2, and phi is equal to 0 to pi. The total function will get the 129.437. Okay. And next example, given that the d bar is equal to 5 R square by 4 in AR bar, evaluate both sides of the divergence of the volume. Enclosed R is equal to 4 meters and the phi is equal to pi by 4. The same, but here it is a given of d bar. In the previous example, it is a bar. D bar dot ds bar is equal to volume integral del dot d bar into dv. But it is not that it is a cylinder in the previous case, now it is a cone. The given d bar has only the radial component as given, dr is equal to 5 R square by 4, while d 0 or it is a d phi is equal to 0. Hence d bar has a value only on the surface at R is equal to 4 meters. Okay. According to the Gauss law, the d bar dot ds bar, R bar, ds R bar along the direction means we have only the R into d phi dz. Similar AR bar. Okay, but here this is a function for cylindrical coordinate system. Now we are assuming the cone means definitely that is a spherical coordinate system. Spherical coordinate system is r component is a dr and theta component is r into d theta and phi component is r sine theta d phi. So along the r direction means this is for cylindrical. So ds r bar is equal to for spherical coordinate system along the r bar direction. R into r is r square sine theta d theta and the d phi. Now I can apply the d bar dot ds bar. D bar is given as 5r square by 4 into ar bar and ar bar dot ar bar can be moved is a 1 and r square sine theta d theta and d phi. For this you can apply the integral 5 by 4 r power 4 is a constant. 5 by 4 r power 4 is a constant and integral sine theta d theta and is given it is a 45 degrees only. So theta is equal to 0 to pi by 4. Actually it is a 180 degrees and phi that rotates 360 degrees. So 0 to 2 pi d phi. Now the integral sine theta minus cos theta. Substitute here the 5 by 4 r power 4 minus cos theta pi by 4 and 0 and d phi is 2 pi only we get. Cos pi by 4 is 1 by root 2. So 5 by 4 into r power 4 and here we'll get the minus. Put the minus is outside. The cos pi by 4 is 1 by root 2 minus cos 0 is a 0 is a 1 and into 2 pi. Okay. Let's simplify by substituting r is equal to 4. R is equal to 4. Then what is the value we got? 588.896. So r is equal to 4 here. Cos pi by 4 is a 1 by root 2 minus into minus is a plus here. Or otherwise you can take the minus as a common and simplify the function. And in the right hand side, the divergence del dot d bar. Right hand side is a volume integral. Left hand side we find right hand side del dot d bar. The formula here, the previously 1 by r into dou by dou r of r into ar bar, not the r, dr, let us take so in terms of dr also. The same thing 1 by r into dou by dou phi into a phi. That is a d phi, let us take. I'm taking the d phi, dr, and the last one is a dou by dou z of dz. This is for the cylindrical coordinates. Divergence formula, the del dot d bar is equal in terms of the dr component, d phi and the dz. But in the spherical coordinate system, del dot d bar is equal to the divergence of d bar 1 by r square. Just here the 1 by r of r square into dr. So here the r into dr. Similarly, plus the component having the r sine theta is so r sine theta dou by dou theta of sine theta into d theta. That is the second coordinate. Similarly, the 1 by r sine theta dou by dou phi of d phi. This is a formula for the divergence of spherical coordinates. So what is a d given 5 by 4 pi r square? R square. So there is no any phi component, beta component, both are the zeros because the constant and the del dot d bar is equal to 1 by R square, dou by dou R of R square is given R square and the dr coefficient is a 5 by 4 R square. That is equal to R square into R square is R power 4 and its derivative is a 4R cube and the pi by 4 is also there. 5 by 4, 4 get cancelled, R square and on 1 R square get cancelled, 5R. Got it, my students? Here the 5R, the right hand side. And in the spherical coordinate system, the volume integral is equal to the volume integral R square sine theta dr d theta d phi. All the components is a product. What is a del? We have del dot d bar, we got 5R and substitute the dv is equal to R square sine theta dr d theta and d phi. And R is given from 0 to 4 because R is equal to 4 meters. And the phi is as usual 0 to 2 pi. And the theta is only the 45 degrees. Substitute and find the same thing, 588.896, the left hand side and the right hand side, what we got. Okay. Coming to the next example, the similar way. Find the total charge in a volume. Find the total charge in a volume defined by the 6 planes for which x is varies from 1 to 2 and y is varies from 2 to 3 and the z is varies from the 3 to 4. The d bar is given. The same thing, my dear students, q is equal to integral d bar dot ds bar. For x is equal to 2, for x is equal to 2, all it is, they are saying it's a 6 planes, ts, nothing but differential surface area normal to x direction. So, we have only the dy and dz. Similarly, for x is equal to 1, differential surface area normal to the x direction, we have dy and dz only. Got it, my dear students? For the first function, hit the ax there, d bar is equal to, and I can apply the d bar dot ds bar, and the ds bar is equal to dy and dz into ax bar, and here for this one is dy and dz into ax bar because it is the direction is a back surface, so it is a minus, front surface is a plus. Similarly for the y, 3 and 2 is there. The right side is a y3 and the left side is a y is a 2. Left side we can take it as a negative value. It is in the y direction. Differential surface area normal to the y direction. There is no any y component. Dx and dz only. Similarly for this, the second one is also dx and dz, but it is a negative direction. Got it, my dear students? And the z value also, z is equal to 4 and z is equal to 3. Z is equal to 4 and Z is equal to 3. Z component along the surface means there is no any Z component. ds Z bar is equal to dx and dy, and is a bottom means negative direction. Okay, by using this front and the back surface, right and the left side, and top and the bottom. By using all the functions, find the total charge in a volume defined by the 6 planes. Calculate and you can substitute, my dear students. And coming to the next example, find the flux density within the cylindrical volume bounded R is equal to 5 meters and Z is equal to 0 to 2 meters, given the d bar is equal to the same thing. What is the total outward flux crossing the surface of a cylinder? Okay. So the given the cast as a total outward flux is asked, all the surfaces lateral, top, bottom must be considered. Consider the lateral side. the normal direction to the AR. The lateral side means definitely you get the AR bar only along the AR bar direction. Differential surface here, because it is a cylindrical coordinate system. ds R bar is equal to R into d phi dz and AR bar. Okay, when it is in the vector form, R d phi dz AR bar, lateral side. And d bar dot ds bar is equal to, d bar is given 30 into e power minus or AR bar and minus 2z AZ bar. Already we used one example there, but here they are finding, they are asking what is the charge. D bar dot ds bar. Okay, AZ and AZ is a 0, AR and AZ and AR bar is equal to 1. So 30 R e power minus R and d phi dz. Check on the gas law, the psi 1 is equal to the lateral side. If I am now finding the charge enclosed, or the Q is equal to also the Q and the charge flux is both are the same here. There, the gas law, Z is given 2 meters and 0 to 2, and the phi is equal to 0 to pi. The psi 1 is equal to 12.7. Now consider the top surface. The top surface is along the normal to the Z direction. Normal to the Z direction means AR and AZ is a 0, minus 2Z R dr d phi. The second flux psi 2 is equal to the top d bar dot ds bar. In this dr and d phi only, R is equal to 0 to phi and pi is equal to 0 to 2 pi. With the Z is equal to 2. We got the value is a minus 314.15. The bottom surface, d bar dot ds bar is equal to bottom surface the AZ bar, because and is a bottom minus AZ bar. With respect to the region, the differential surface area normal to the AZ bar, ds AZ bar is equal to R dr d phi. There is no any dz along the z direction, and it is a minus R dr d phi minus AZ bar. So AZ and AZ here, the minus to minus is a plus 2Z R dr d phi. With the Z is equal to 0, the term is a 0. The bottom term. The psi 3 is equal to 0. The total surface, the total flux we have, psi 1 and the psi 2 and psi 3 will get minus 301. So what is the first one here? This first value we got 12.7 plus, or the plus here, minus, I think, minus value of minus 314.1592. So subtract here 14 and here the 2 will 12. That is a 301.45. The term is a 0, the last one. Subtract these two and we'll get the minus net charge. Not the charge, is a flux psi is equal to, or the charge Q also the same. Got it, participants? These are the very, very important topics.